Hello ladies and gentlemen, welcome to my tutorial video on how to use LabQuant for gel images analysis. So first things first, you need to open Matlab and reach for the LabQuant folder here on the desktop. So you'll probably load on users or go to users, choose the rightful user, and then go to desktop and select the LabQuant folder here. So this is the LabQuant folder. So it is composed of 3 different folders. So there is the function folders, and this is all the functions needed for the software. So do not modify or do not touch this folder. The second one is the gels. So this is where you will put all the gels that you want to analyze. And the last one is the area report and the graph report. So this is all the outputs. So all your results will be generated inside this folder. All right. So it is really important that when you want to launch the software, you see the labquant.m file. So this is the main launcher for the software. So here is the demo image that you want to analyze. So you need to drag it inside the gel folder here. You see it's here now. So this is the image that I will analyze. So I can now launch the software. To do so, I can either write LabQuant inside the common window here, or alternatively, you can right click on it and then click on run. So this is what I will do. So software is launched. So the first input options is to select the image that you want to analyze. So here I need to enter the file name. So let's replace this with the exact name that I want to analyze. So here's demo.gel. So I write demo.gel here. For gel files, usually there's an encoding that you want to remove. So here you can do so by clicking on square root encoding. So if your image does not have any encoding prior to your analysis, then you can select the no encoding. And the last option is the correction factor. So the correction factor accounts for the different binding affinity of supercoiled DNA and cybergreen. So this is the corrected area report that you want. In my study, I used 1.5 as recommended by the literature, but if you do your own digestion experiments and you find another value, you can modify it here. Let's leave it to 1.5 for now. So I'm done with the input option. So here is the image that we want to analyze. This is the demo.gel, so you can enlarge this. And this is the user options window here. So the first thing is the native image background. So when you load the image, you see that all the background is black. So this is the option that you want. If the background is white, then select white background. After, you enter the number of lanes. So usually you would take something like 15 lanes. For here, I'll just select 3 lanes to quantify. So this is the number of lanes that you want to quantify. The next step is maybe you don't want a black background. You'd prefer a white background for analysis because you can see the bands a little bit better. So you can invert gel image here, and this makes the white background that you're most probably used to. So let's use this. So now I can select my 3 lanes. So click on select lanes and then pick 3 lanes. So let's pick this one. So to do so, you need to left click on the top and then hold on the left button and then just drag it until you're done and release it like this. So left click, hold until you have the complete band and then release it. Suppose that I'm not satisfied with my lane selection, so you can always refresh or clear gel. So this will just reinitialize everything. So click on this, and then it erases everything, and you can select again. So let me reselect here. So I'll pick this one, pick this one. So you see here that you cannot clearly see all the lane selection, so it's preferable to invert the image first. So let me just refresh and invert, and then I can select the lanes. So like this, the first one, the second one, and the third one. All right, so I'm satisfied with these lanes, so I'm done. So this is the lane selection part. Let's enter the band quantification part. So here you can save the graph result. So it's the intensity along these lines that you can save in an Excel file if you want to recreate the graphs. So I click yes. Okay, so here are the intensity graphs along those bands. So you can select a subset of your bands to quantify. So if you only want to quantify band 3 or lane 3, so you can uncheck those two. But for this example, I will leave them checked. So those are the graphs that were just saved in the graph report here. So all the values that you need to recreate those graphs are stored in the graph value files. Alternatively, you can save the figure here. So if you don't need the values, you just need the figure, then you can save it here. So I want to quantify all three. So I check them all three and click done. So now it's the quantification part that begins. So you see here is band 1 or lane 1. So you need to quantify all the peaks. So the first thing is to identify the peaks. So to do so, you need to click on the left where the peak starts, and then you click on the right where the peak ends. So it starts about here, it ends about here. So you left click on both sides. So here I do it again. It starts here and it ends about here. And for the last peak, you want to know the software that this is the last peak, so you click on the left. And to indicate that this is the last peak, you need to double click on the right. So I just clicked once here and double click on this side, right? So this was the peak identification segment. So now you select the baseline. So here you just click on the left and you see that you can draw the baseline. So you double click on the right to indicate that the baseline is done. So you need to do this for each peak. So let me do it here also. So left click and then double click. And here the same thing. So left click and double click. So you see all the area that will be quantified. Here it says, are you satisfied with the quantitation? You can say yes or no. Let's say that I am not satisfied. There's something wrong, or I misclicked something. I forgot a peak. So I click no, and it reinitializes everything. So let's do this again. So left click here on the left, and then on the right where it ends, and do this for each peak like this. And for the last point, last peak, you double click. And then you choose the baseline. So one click and then double click like this. All right, so I'm satisfied with this. So let's go to lane 2. So I basically do the same thing for all lanes. So you can pick up speed along with experience. So click on the left, on the right. Here we see that there's an additional small peak, so let's identify it. So click on the left, click on the right, and then the other peak here starts right after this one ends. So let's put a point here, a point here. Same thing for the last peak. And we need to double click here. So let's double click. All right, so peaks have been identified. Now we need to select the baseline. So same thing as earlier. You need to do this for every peak that you have identified in the previous step. So I do this and I'm satisfied. So let's do this one last time. So the peak starts here, it ends here. Here there's no small peak, so let's just take 3 peaks for this one. And I double click on the last point. And now I select the baseline, like this, like this. All right, so all the peaks have been selected. I'm satisfied with this quantitation, so I click yes. So now the software does all the calculations and measures the area and everything else. So it tells me when the analysis is done. Here, analysis is completed. Should take only a few seconds. If you have the more peaks you have, it could take longer, but it should not take more than 10 to 15 seconds. All right, so analysis is completed and successful. Area report should be found in the output folder. So remember the output folder in Matlab. So this is the output folder. So the area report, this is what you're mainly interested in. So the format is area report, and after all the numbers, it's the date. So it's 2019, 8th month, so August, and 9. So the 9th of August. And this is the time. After the T, it's the time. So it's just 2 p.m. here. So you can either open that in Matlab or you can open it in Excel. So those are all Excel files. So you can go in LabQuant folder on your desktop and open the output folder, and you will see here the result. So this is the one that I just created. So let's open it. So the structure of the file is you have the lane ID. So here we quantified 3 lanes. So lane 1, 2, and 3. And those are all the peaks that we identified. So for the first lane, we identified 3 different peaks. For lane 2, we identified 4 peaks. There was this small additional peak in the middle. And for the last lane, we have 3 peaks. So here is the absolute area, the corrected absolute area. So this is taking into account the correction factor for the different binding affinity. And here is the corrected relative area. So this is a percentage here. So this is the value that you are most likely interested in. So for peak number 3, it should add up to 100%. So this is the values that you will use for your analysis. So for example, here it would be this peak is the last peak, so it is associated with the supercoiled DNA, so it's 86%. All right, so this is for the area report. If you want to recreate the graphs, you can open the same graph report here, and this is all the values that you need to create the graph. All right, I think it sums it up. Hopefully you will use this software, and if you have any problem, you can ask me either on YouTube or write an email to me. You probably know my email, so make good use of this software, and have a wonderful day.